Hello, this is checkpoint 4.25. They want us to calculate the derivative of w with respect to u and derivative of w with respect to v. And f is a function of three variables, and x, y, and z in turn are functions of two variables. If I were to draw a tree and take advantage of the chain rule, I would draw my tree as a function, as f is a function of three variables, x, y, and z, and then each of these in turn are functions of u and v. And then we would follow paths to take the derivative of f with respect to u, or w with respect to u. We would follow the paths from the original function to u's, all the u's that we have. And so we can write the formula for that as a partial of f with respect to x times the partial of x with respect to u, and then the partial of f with respect to y, partial of y with respect to u, and then the partial added the partial of f with respect to z times the partial of z with respect to u. And that is our partial of w with respect to u. And similarly, we can do the same thing to find the partial of w with respect to v. Now, we're going to do things a little bit differently for this video. And what we're going to do, instead of using the chain rule, let's see how it would look like if we actually plugged in the values of x, y, and z into the expression. What do I mean by that? We're going to take a look at f, now putting in the function itself, uv, x of uv, y of uv, and z of uv. And so we can view this as a new function. Maybe we'll call it g independently as a function of u and v. All right, how's that going to look like? In for x, we're going to put in our x function, e to the 2u cosine 3v, and then we have a plus 2 times e to the 2u sine of 3v minus 4 times e to the 2u. Okay, that takes care of our numerator. Our denominator is going to be 2 times e to the 2u cosine of 3v minus e to the 2u sine of 3v plus 3 times e to the 2u. All right. There's an interesting thing that happens here. Each of these terms on both the numerator and the denominator has an e to the 2u. And so we can take that out and cancel them all in one step. And that's what we'll do. We'll get rid of all these. And now what do we have left? We have a cosine of 3v plus 2 sine v minus 4. And we have 2 cosine 3v minus sine, it should be 3v, and plus 3. Now notice that this has no u variable. So that's interesting, because in the previous checkpoint we saw that the derivative became 0, and this is exactly what would happen if you tried to take the derivative of w with respect to u, and that's essentially taking the derivative of this function with respect to u, and there are no u variables here, so that is just 0. Okay, that saved us a whole bunch of steps had we used the chain rule. But, you know, that's just what happens in this particular scenario. It could be different for other problems. It might not all be zero. In any case, we still have to find the derivative of w with respect to v, which is essentially the derivative of this new function that we found with respect to v. So let's take the derivative of that with respect to v. It looks like a big quotient. And so that would be the low. That's 2 cosine 3v minus sine 3v plus 3. D high, the derivative of the numerator. Derivative cosine is negative sine. There's a 3 that pops out every time we take the derivative because of the chain rule. And then we have a 2 times that 3 that would pop out. So that's a 6. And then derivative sine is cosine 3v. And then derivative of negative 4 is 0. So that's low d high minus high. That's the numerator. Cosine 3v plus 2 sine 3v minus 4 times the derivative of the denominator with respect to v. And again, the derivative of cosine is negative sine. There's a 2, and then an extra 3 that comes out that makes a 6. And the derivative of sine is positive cosine with the 3 that comes out. And then all divided by 2 cosine 3v minus sine 3v plus 3 quantity squared. Okay. Now, I'm sure there's going to be some ways to simplify this, and you can FOIL things out and simplify everything out. But I'm just going to go ahead and leave it at that and be done with this problem. Okay. All right, so this is a different way from doing the chain rule. This is putting the values in, but this is just another perspective, and I encourage you to use a chain rule. There's a write-up of this in a PDF version, so you can view that, take a look at it, and compare it to this. Okay, I hope that helps.